If I get you put your hands together for my next presenter, Jess Portnoy.
Hi, everyone. Good morning. Great to have you to join me here for this session. So I'm Jess. I work for Kaltura. What we do is an open source video platform. So essentially, we handle all your video content from the moment you stopped shooting it up until your viewers actually view it. It's a very interesting platform. I wouldn't be going into that because it's not the focus of our session, but I'll be showing how we're monitoring our platform using Nagios. It's a clustered environment. It has a lot of server roles. So we'll just start by talking about that. And of course, if you have questions at the end, I'll be happy to answer them. So let's go. All right. So at first, what happened is our product management came to me and said, look, a lot of our customers are asking about monitoring, and we need to come up with a sort of a suite for them to be able to monitor our their production environment. So I said, OK, the first thing we need to do is start by utilizing our API, because what Kaltura does, we extend a RESTful API, which means that you can basically do anything from outside our platform as you can do from the inside. And so it's very easy to monitor because you can just probe it for any information by making very simple HTTP requests. Of course, they're session, right? I mean, you need to establish a session first, but you can, all the information is exposed provided you have the proper session. So that's key to achieving the correct sort of infrastructure where you can monitor everything. And the added value is that all our functionality is also being accomplished by making the same requests. So the monitors, in effect, do exactly the same thing as the end user would do, in a sense. So whatever the end user does from their browser, it's of course web-based, so everything is browser-based. Whatever the user does, we can do programmatically via a monitor. So that's very useful. So you can really say, OK, I'm exactly imitating the exact actions that a user would be taking. So that's key. So I said, OK, look, let's choose Nagios as our base. My reasoning for that was that, A, I really love Nagios. But I've started with Nagios when I think it was the year 2009. I was working for a financial provider. I mean, a software provider for financial operations. And what I like about it the most, apart from it being open sourced, is that it's very flexible and very simple. Right? It works with the KISS principle, the keep it simple, stupid. And it's very simple and yet very complex, which is also what's being said about Unix, by the way. So you can really, the idea of it is very simple, and you can generate configurations very easily using the command line, using the pipe and set and awk and so forth, in a way that it's very easy to manage and is very straightforward. I am fortunate in that our platform works exclusively on Linux. So the challenges of trying to hook up monitors with, well, I don't know if to call it an operating system, but let's say operating systems like Windows, is not there. So I'm very fortunate in that. I can do all my probing using HTTP requests and SSH requests. So let's get started. Before I get started, I want to present my cat, November. She was very angry that I'm leaving home, so I promised her that I'll be showing her picture. So this is November. I'll give her a videotape of the session or something. OK, so as I said, we considered various alternatives. Of course, we're only suggesting Nagios as our monitoring platform. The customer can do whatever he wishes to. But since all our monitors basically rely on our API, and with Nagios, they're just scripts, these scripts that follow a certain convention of return codes, basically. So even if the user is not interested in using it within the context of Nagios, or any monitoring system for that matter, they can just run it from the command line and monitor the results, which was important to me, because I wanted to build something that's flexible and manageable from whatever monitoring environment, even if it's just a cron tab, for that matter. So that was one consideration. Nagios is very commonly used, of course, which is a very important point. I think a lot of times people don't put much emphasis on rather the software is commonly used as an open source software or not, because you have a lot of commercial solutions which are expensive and they have a huge company behind them, but that doesn't necessarily mean they have a large user base. And a lot of times you'd get more support from the community than you'd ever get from a commercial product, because it's very easy to post to a forum or to Nagios Exchange or to anywhere else for that matter and find talents that are willing to help you develop your business free of charge or by paying, than it is to submit, a support ticket to some company. It takes them a lot of time sometimes. And for Nagios, what I like is that it's both open sourced and a company. So you get advantages from both ends. It's, in that sense, it resembles Kaltura, which is also a commercial company with an open source base. So I kind of liked that, and it felt right for me to use that solution. It kind of felt like it goes along the same territory of what we're doing. So it felt like a right match for us. So of course, and there's Nagios Exchange. I'm sure everyone's familiar with it, right? No, show of hands, anyone unfamiliar with Nagios Exchange? Everyone are, good. I also host a few plugins there myself. And it's very easy, as I said, to build upon Nagios, because all you really need is your scripts that follow the conventions of return codes and basic knowledge of how to edit the configuration files. This session is only going to cover core. We're not making any recommendations as to higher up platforms for monitoring. Some of our customers do use them, of course. Universities seem to be very into Nagios, and they're also very into Kaltura. So that's a good start. When we come to a customer and we tell them, yes, we also have a basic monitoring suite for Nagios, they're very happy because a lot of them already use that. So it's a good selling point. So let's talk about our basic platform, what a Kalturian cluster consists of. So we're running on Linux CentOS, and of course RHEL. It doesn't matter to us. It's the same thing, basically. We use Apache. This particular demo is using these versions, but any Apache 2.2 and any CentOS RHEL 6 would be fine. MySQL 5.1 and PHP5 3. Our entire core is built by PHP exclusively. Our front end has some Flash, but the entire core, the API, everything on the back end is all PHP based. And so our monitoring are also PHP. We do extend API client libraries in various other languages, such as Ruby and Python and various others, but seeing how we're a PHP shop, it felt more reasonable to base our monitoring on PHP scripts. It's also the most common language within our company, within our R&D, so it's good that everyone knows the same language. We also have external components. They're all open sourced, so we use memcached, and everyone's familiar with memcached? I see some nodding, so I guess the answer is yes. And we use a lot of PHP extensions for various operations. We use FFmpeg because what we do is we optimize the source video so that it looks as best as it can look in various client devices. So naturally, a certain source would need to be converted to a different sort of format for, let's say, iPad, and then for a PC, and for a mobile device, a cell phone, for that matter. So we try to optimize it the best we can. We have a decision layer that operates on top of FFmpeg, which is an open source project, and basically analyzes the input video and outputs the best quality flavors that it can based on the user definitions. So a user could say, well, all my customers, it's an internal network, they don't use any mobile devices, all they use is PCs because it's a corporate network, so we just optimize for PCs. Another would say, yeah, sure, I have customers using iOS, have customers using Android, different ones are using PCs and so forth, and you can really just define as many flavors as you'd like, and our system would optimize your input videos as best it can in accordance to these definitions. So that's FFmpeg. We also use Sphinx. Sphinx is a full search text engine. What it does is act as an intermediate layer between MySQL and our API, so that our retrieval from the database would be faster, the searches would be faster, because MySQL doesn't do well with full text searches per se, it's slow. So we index using Sphinx, and then the requests return faster. So that needs to get monitored as well. This is the basic architecture of a small cluster. So as you can see, we have front servers which run Apache. KMC is our management console. It's written in Flash. We have our API, and we have Sphinx. We have an admin console that allows the user to administrate the cluster. A MySQL DB, of course. Batch machines that are just PHP machines running our code and making operations. And we have NFS for saving the content, the various videos and related files, so that it's accessible throughout the cluster. So that's the basic topology. I want to show you a demo, and the demo would consist of several parts. First, I would like to go through the various tests that we have. This is a very basic cluster. Of course, there are many bigger, wider clusters out there. But I want to show how we've written some tests for it, just go through the flow that we're using, and then show a demo of how one of these monitors come to life. So that's what I'm going to do. Just to show you the platform for a second, what it looks like. So this is our management console. You can upload videos here. Hold on. And they're converted to various flavors. And then you can, of course, embed them, play them. There are a lot of functionalities, of course, but this session is not about that. So I can't possibly go into all the details of what our platform does. But we will show a bit of it. So here is my Nagios instance. It has a very simple load balancer using the Apache HTTPD proxy model. So just a very basic balancer balancing two Apaches behind it. I'm using a lot of standard plugins here. All of these are just the basic suite, the one to monitor HTTPD, network time protocol, which is very crucial for our environment. Well, for any environment that's clustered, really, but for ours, it's very sensitive. Just monitoring the file system and so forth. And now we get to our own specific monitors. So the way the architecture works is that you have the batch machines, which basically are Apache machines running PHP code, and you make HTTP requests to it asking for jobs. So a job could be transcoding, taking the video and converting it to various flavors suitable for viewing for various devices. It can be sending an email. It can be a cleanup job. It can be a lot of things. And all those things are queued by making RESTful requests to our API. That's basically how it works. So this particular test, which we'll see the code for in a second, just checks the queue to make sure that there are a certain amount of jobs pending. This is important because sometimes a customer would have like a lot of content rushing through. Let's say that you're in a conference and you're taking videos of the conference. So you may be putting a lot of load onto the queue of the batch. Now, what you could do is monitor that and actually be proactive about it. And when the queue rises to a certain amount, you can instantiate new instances of batches. Today in the cloud, it's very easy. I mean, it's just like that. We have integration with Chef that can do it for you in a second. And then you can, once the load decreases and the monitor is healthy again, you can take them down, thus not paying for the instance anymore. So that's pretty important to monitor that load. Let me just show you a bit of code here. By the way, it's all on GitHub as well. Let me open that one too. There are links at the end of the presentation, so you don't really need to write it down or memorize it, but this is our GitHub repository. Can everyone see okay, by the way? Yeah? Okay. So let me just find my Nagios instance here. I got disconnected from everything. Give me a sec. Sorry about that. All right, here we go. So this is my Nagios instance. I have divided our configuration files in a way that I felt is the best way to divide them, so that we have our Kaltura services in a separate file to differentiate them from general health system checks, like partitions and RAM usage and so forth. And they're really very simple in essence. I mean, the configuration is very simple and easy to read through. You can see that I've divided them into various groups because, as I said, we have various server roles. So we would have one for the load balancers, another one would be for the NFS machines, and the third would be for the front servers, which are serving content to the end user, I mean, web pages, essentially. And then we'll have the batch servers and Sphinx and MySQL. And each of these groups would have a various different set of tests to be applied for them, as well as joined tests for anything that's a Linux server, basically. Again, being disk space and RAM and whatever other health tests that are generic. So these are basically our groups. You can see in the presentation that they match. So, sorry about that. Hold on. I just love presentations. Okay, so for instance, there'll be a group for the front machines, and there'll be another one for the MySQLs, and another one for batches, and another one for NFS, and another one for load balancers and Sphinx and whatnot. So that's the general idea of it. If we go and see some commands, hold on. So you can see they're all pretty simple. They're just command line commands. They're using PHP CLI. And we have this wrapper that we've written that is specific to Nagios called exec.php, which wraps all the tests. So all these tests, as I said, can run from the command line directly without any relation to any monitoring system at all. And then we have the exec.php component, the script, that is responsible for taking the output from all these various plugins and parsing it into something that Nagios would expect. So both in terms of output messages and return codes that are the most important part, right? Because that's really, I think, the only convention that is forced upon us as Nagios users. We just need to return the correct code, and then Nagios would know how to handle it. So this is the exec.php. I'm going to show the code. It's very simple, really. Hold on. Let's go to one of our front machines. Say this one. All right, so anyone here who knows PHP around here? Show of hands. All right, cool. But it's really pretty straightforward, so anyone who's familiar with any programming language should get the idea of it. So we define the return codes for us, the constant, so to speak. We have this file that really takes care of, it defines some classes and things related to the result of the monitor. We have an INI file with some environment variables. This one includes passwords. Don't you worry, these are not interesting. Don't bother taking them down. Let me just, sorry here. Okay. So this is a very simple INI, which also acts as a shell resource file. So it can be used from both the PHP code and our shell scripts. Just defines a few variables that are important to us and our monitors as well. So things like what's our password, our IPs, ports, the service URL, because as we said, everything is RESTful, so we just make API requests to one service URL with parameters, and then get the result we want to get. So the service URL is really key, and all our monitors need to know what service URL they'll be requesting. So that's pretty much it. It's very simple information. And once parsed, we continue onward, and you can see that we're creating a regular expression and checking the matches. And this is something that we do for each and every plugin. So this is like a wrapper to provide common functionality we need for all plugins. Easier to maintain in one place. And if needed, it can be easily adjusted. So if, for example, Nagios would add another return code, we could add it here and put the logic inside this without, theoretically at least, touching any of the plugin's code. So that's a good idea. Let's take a look at one of the API scripts here. So you can see that we're calling the wrapper with PHP. We're giving it the threshold, which is for Nagios to handle. And then we call the actual script. So the specific test here would be ping PHP. This ping is not an ICMP ping. It relates to a service that within our API that's called ping. That just does as its name would probably indicate. It just makes sure the host is answering, the service is up, and the API is functional. So let's just take a look at that one. All right, so as you can see, it requires common PHP, which is common to all monitors. Again, we try to encapsulate as best we can so that we do as much code reuse as possible and not duplicate code, which is a common mistake in monitors I've found, because not because the people who write them are not good developers, not at all. It's because oftentimes you're not allocated enough time to properly write monitors for your environment. It's usually kind of the last thing that they tell you to do, and it's always under pressure, and it's always hard to explain to management why. It's important to give time and properly prepare the infrastructure and the monitoring so that in future times you wouldn't curse yourself and be angry at the world. So I found that a lot of times it's kind of a fight against management, so to speak, to allow the time to properly write everything down. I've been doing DevOps for a long, long time, so it's something that I've always come across, like people saying, yeah, I don't understand, but why do you need the time to prepare monitors? And they only understand it when something crashes. And when something does crash, they say, okay, so write something up real quick. So I think monitoring in general should be treated as any other software framework and should be taken slowly and with considerate resources from the get-go, so that you don't curse yourself and come up with an interface that you can't really manage at all, and then end up in a total rewrite after a very short period of time. So this is the common PHP, as we've said. You can see that it's pretty simple here. We have client libraries that are generated, auto-generated from the code. They're just PHP scripts, classes, and so forth. And you can just see that we're trying to make a request for ping, and then we check for the result, and we throw exceptions whenever is appropriate. I'm not going to go through the entire code, of course. It's a large code base, but that's the general idea of it. And all the plugins have pretty much the same structure and just different functionalities. What I would like to show you is a demo of me stressing the upload queue, the conversion queue. So I'm just going to bulk upload a lot of videos, and we're going to see the monitor trigger a critical alert live. So let's just do that. The API allows us to do all that from CLI as well, so it's very convenient for testing. If I want to test that the monitor is working properly, all I need to do is write a very short script like this one. As you can see, it's really very small, just shy of 40 lines, and a lot of them are commented. So it just gets the service URL to which to make the request, the partner ID. Our platform is a multi-partner platform, of course, so you can have several accounts, as many as you'd like, and each of them would have, hold on, sorry about that, an interface such as this one with their assets, their various videos. So, of course, we need to say which partner ID will be uploading to which account. There's a secret, which is a hash. It's saved on our database. And combined, the partner ID and secret combined will establish a session, a Kaltura session called KS. You can have various sessions at various levels. So you can have an admin session. You can have a regular user session. It's just good practice because you don't want to elevate privileges more than you actually need to. So for bulk, a simple user session would be sufficient. We're just reading the arguments here, and this is the money maker will be generating a KS, which is just a long string of characters. And once that's done, oh, sorry about that, we'll just use this service call here, which is bulk upload, and we'll just upload a bulk of content into our account. So if we're looking at the Nagios right now, we can see that right now the scheduler queue conversion is 0. Nothing's going on. Now I am going to trigger this. So as you can see, I'm just calling the service URL. My partner ID is 101. This is my secret. This is my name, just the display name. And this one is a CSV containing several videos that will be pulled from, as you can see here. See, these are just URLs to videos and some metadata about them. So our system would basically parse this one and CURL the content from the server to our server and then start processing it as a batch job. So that's what we'll be doing right now. All right, so successfully uploaded. If we go to the management here, we should shortly be seeing it. There we go. So you see, we've started new processes here for processing the content. First phase would be to upload it, of course. So if we refresh a few more times, we see that some of them are still uploading, and some have started to convert already. Each of these would have several flavors within it, as we can see here. Just a second. Okay, so currently it's still uploading the source video, and then as you can see, we have several conversions here. So customized per, let's say, client and viewer. So some of them would be basic small, and others maybe SD small, and they have a lot of parameters within them. I'll show that too while we're waiting. So if we look here at transcoding settings, which are adjustable, of course. So you can see a lot of parameters about it and the actual spec and the format they'll be generating and the codec they'll be using and the bitrate and the dimensions and so on. So this will be done once the content is uploaded. We'll go through a decision layer that analyzes the video and decides which flavors are applicable for it, because naturally if the quality is very low, some of these flavors may not be feasible to convert to. I mean, we're not magicians, we're software engineers. So this is how it works. I would think that right now in Nagios, it should start showing that it's progressing. Yes. So you see, before it was 0, and now our queue size is 17. So we're currently converting 17 of these. Naturally, I gave a very low threshold. Of course, we can handle much more without it being critical. But for the demo, I gave very, very low thresholds. If we go to our server, let's go to a batch server here. This cluster has 2 of them, by the way. But of course, it scales, and you can have I don't know, even 100 of them if you want to. All right, so you can see that there is a PHP job, several of them going on here, and FFmpeg should be one of them. Okay, so you can see our system has analyzed the video and then started to launch FFmpeg processes to handle it with various parameters that came from our decision layer. So that's the basic flow. You know, it uploads, then once the file is on disk, an analyzing process begins to understand what sort of video this is and what can become of it and how it can best be what it should be. We use media info to understand the video spec. That's another open source project, media info. And then we decide how to utilize FFmpeg in order to best convert it. So that's the idea of it. Other monitors that we have here that are related to Kaltura. So for instance, Kaltura has two players. We have the older Flash player, which is called KDP. That's the Kaltura dynamic player. And we have a new player that's called the HTML5 player, of course, which is the next generation. KDP is almost deprecated, but still being used. So this test, for instance, makes a request to playback and tests it programmatically without anyone having to actually press play anywhere. So that's one test. There's a parallel test for KDP. We have a widget session for PS2 is partner services too. We have two generations of API. So PS2 is the older one, and now we have API v3. So that's the newer version. We have a check for the memcache daemon. By the way, this one I took from Nagios Exchange, but I did make a pull request to it, which is actually nice. I mean, that's what I love about working for both an open source company and with open source projects, is that I get to contribute constantly and get contributions all the time. So even as I was working on this presentation and these monitors, I was able to make some pull requests also. So that's very nice. This monitor, I have URLs for each and every monitor that we're using in the end of the presentation. So we also have a connectivity check, of course. We have a database that's MySQL. And you can use master and slave as well. This one only has a master because it's demo, but of course you can also have a slave replication. We're checking the Sphinx integrity. So as we said, Sphinx is used to offload from MySQL so that the queries return faster. So we need to check on that. That's a very core component, because if the Sphinx server is down, you wouldn't be able to see content served to you because searches wouldn't work. So for instance, if Sphinx would be down, then this view might be empty altogether, because looking up the entries wouldn't work. As you can see, by the way, the entries are already done with and converted to all flavors, and so I would imagine the monitor would now be green. Just find it. All right, so we're at 11, decreasing slowly and becoming sane again. This is why, because each and every one of these, even though they're already ready, the reason they're said to be ready is that at least a few flavors converted successfully already, so the content can be played. But it doesn't mean that it's done converting to all flavors, as you can see here. So for instance, this one is done, so a user may now play the video, but they'll only receive this one particular flavor that's ready. It's not necessarily optimized for their own device yet, but it'll play immediately. And once these are done, then the user will have a bigger selection of video qualities to play. Of course, this is done automatically. You don't have to say, I want to play an entry that is on iPad. This is auto-detected, of course, by our player. And it knows how to make a request and choose the best flavor to your, as per your device and your bandwidth and so forth. But the important part is, as soon as one of these is ready, you can at least view the one while it's converting to the other ones. And this is why the monitor still says that we're at 10. Because even though all assets are done, not all flavors, sub-flavors are finished yet. So that's the reason why. What else have we? You can see the regular tests, of course, that are partition and SSH and other things that are mandatory for our system to function. There's another one about the NFS that I'd like to get into. Yeah. So this test is actually a plugin I've written and is available on the Exchange. What it does two things. It makes sure the mount is active and writable, but it also makes sure there's no delta between what you have on your FS tab and what is currently mounted. And this is important because sometimes you do an operation really fast and you'd mount it manually from the shell, but neglect to add it to FS tab, meaning the next reboot you're going to lose that mount. So it's important to monitor for those things, especially if you have a lot of mount points and a lot of servers. It really quickly gets out of hand. So this monitor makes sure that A, the mount is writable, and B, that it actually has an entry, a matching entry in FSTop. The other way around is also important to check because sometimes you would hastily mount something just to, I don't know, copy something to one place or the other and forget to unmount it, which may pose as a security hazard. So that's also important to check. So that's another monitor that we have. I think that pretty much concludes the basic reviewing of a very, very basic cluster. Of course, it can get way more complicated than that, and we have clusters consisting of tens and even hundreds of machines sometimes. But that's just a basic example of what our platform is and what we use Nagios to monitor. I'll take questions if you have any.
Any questions? Here we go.
What are your success criteria for the HTML5 player? So when you're looking at that, are you looking for a specific screen grab, or is it played in a correct amount of time?
Well, the way it works is, if we go drill down to the process, is this. Our player goes to the API server and says, I want to get a play manifest. Now, a play manifest would be, it depends on the format. There are several formats of play manifests depending on the protocol that you're using. If you're playing HD, then it's one way of manifest. If you're playing for iOS or well, any HLS device, the play manifest would look a bit different. So what you do is our player goes to the server, says, give me a play manifest. Server returns something that resembles an XML usually, that has metadata about the asset, like the bitrate and other variables, and also the URL for the actual video. And then that video is played. So this test basically checks that the server returns a proper manifest and that the asset within that manifest is accessible. It doesn't check the player's end in that sense. It does a backend check. For testing the actual HTML5 player, we have a third-party service that does that checks it on various browsers, which is important. But this is not covered here.
Okay, great.
Any additional questions? Just remember, if you're thinking it in your head, somebody else is probably thinking it as well. So don't be shy. We have plenty of time.
So you had some abstraction between the Nagios check and what you actually ran to get the information. You had some exec.php that you gave a file name.
Right.
What was in that other file name? Is it used somewhere else, and is that abstraction being useful for you?
Well, I'm not sure I understand the question, but I'll try to answer it. And if I didn't get it right, then just tell me. If we go to the monitor that I was demoing, hold on, let me find it. Okay, so this is the wrapper that we talked about, and this is the script that checks the queue size. So basically, I could run this one manually without using the wrapper at all. I could just do this. If I'm going if I go to the server here, oh, sorry about that. Let me just clean the space here a bit. Okay. Oh, of course I need to replace that with the actual host address. So let's do batch 0. Okay, sorry, 1 sec. All right, so as you can see, this is basically just calling the script directly. And this script is a simple PHP script that accepts these arguments, the service URL, which in our case, since it's clustered, I'm asking the load balancer to decide which which API server to address. So it can, the topology here is very basic, so we have the one load balancer and 2 servers behind it, but it can be 50 or whatever other number. And then I'm making the request, telling it the service URL, telling it what job type I would like to monitor, because there are a lot of them. As we said, batches handle more than just conversion, because they handle email sending and they handle cleanup operations and various other tasks, a lot of them really, export operations, whatnot. So in this particular case, I'm interested in the conversion queue, but I could ask for anything else as well. And then I'm starting a session, as we said before. We've seen how I do it from the command line, putting in a partner ID and putting in you know, a secret. The batch server also uses a partner ID. They're called system partners. So for batch, if I want to monitor it, I have my own partner that's dedicated for batch with specific privileges for batch and its own secret. So whenever I want to monitor something that relates to batches, I use that particular partner and its secret, and I can make API requests asking for various information. So I'm starting a session with that particular partner. This is how I obtain the partner ID and the admin secret for it. It's all in a configuration file. I'll show it to you. It looks like this. Okay, so you can see here that I have my monitoring partner, a dedicated partner for monitoring, because I don't want to use any actual user partner, so to speak. I have a batch partner, and it has an ID and a secret. The system partners all have fixed IDs, so the batch partner would always be -1, and the secret would, of course, vary. It's randomly generated for each environment, of course. All right, so I'm starting a session with this, and then I'm getting back a KS, which is a Kaltura session. It's just a long string of characters. And once I get that, I create an object called work queue filter, and I am telling it the job type that I'm interested at. And another object that is a job filter. This is really internal logic to the platform, and I would be very happy for all of you to try and download and play with it. It's all open sourced, and I'm the community manager for it, so we're looking for volunteers all the time. Whatever talent you have, monitor writing or otherwise, we'll be very happy to have you as a community member. And then we just get the queue size, as you can see here. We set the description for the monitoring result. This is an object you can see here. So we create the Kaltura monitor result, and we set the description for it. And this is what would end up being displayed as the message here. So you can see a schedule queue for convert and so forth. So this is the actual output that the exec PHP would output back to Nagios. So that's the basic flow of it. And of course, everything is caught if there are exceptions and so forth. And you see that it echoes the monitor result. It's going to echo it back to the exec wrapper, and the exec wrapper is going to handle the rest of it. Does that answer the question?
Yes, thank you.
Any additional questions?
So being that your platform is based on Linux, and how well has using Nagios been received by your clients? Is it something they're willing to do? Do they have the expertise that takes to get a Nagios instance up and running, or is that something that you help provide them as part of your services?
Well, our professional services do not erect Nagios instances for them, but we do assist with the configuration, and we have templates for all of those. So it's really it's a really no-brainer for a sysadmin that knows how to edit configuration files, and of course we'll consult if necessary. But we do provide all the templates, and we have this entire bundle on Nagios Exchange, and we have examples. They're all in the presentation, in the back page of the presentation. You can look at the URLs. We've found that customers are very happy to use Nagios and usually are already using it, which is one of the reasons we wanted to go ahead and prepare configuration for Nagios. And now again, this is of course a recommendation. We don't require them to use it, but we found that a lot of customers are very happy to see it. It's a well-established platform, and if they already have it in place, then it's the easiest thing for them in the world. And as I said, these scripts are usable from the command line as well, so if a customer does not want to use it, then they can do whatever, but we do push for them to have a certain monitoring system in place, and our recommendation would be Nagios. So.
All right, well, if I could get a nice big round of applause for Jess Portnoy one more time. Thank you so much, Jess. Very
Thank you.
informative.
Thank you for coming. Great having you.